Section 7.2 Estimating a population mean. Definition: a point estimate is a single value used to approximate a population parameter. What is a population parameter? Population parameter is talking about the population mean, population proportion, population standard deviation, or population variance. And what is a point estimate? And actually, we learned how to find the point estimate already from the chapter 3. We know how to find the sample mean, right? And sample mean here, this is a single value. And we use the sample mean to approximate a population mean. Or we know how to find the sample proportion. And sample proportion, this is a single value. And we use this single value to approximate a population proportion. Same idea with the sample standard deviation. Single value to approximate a population standard deviation. And the sample variance also. And this is called the point estimate. And we got the idea how to use the formula to find out these four guys from the chapter 3. And these sessions, we want to find the confidence interval. Confidence interval, this is a range of values used to estimate the true value of the population parameter. The idea is really similar to the point estimate. We will construct a confidence interval, and this is going to be a range of values. Instead of a one single value, we will have a range of values. And we will say we'll be estimate the true value of the population mean will be lying on this range of the values. Same idea with the proportion. After we construct the confidence interval, this is a range of values. We're gonna say the true value of the population proportion will be lying in between these two values. So same idea, we could construct a confidence interval for population standard deviation, construct a confidence interval for population variance. So the only difference between point estimate and a confidence interval, point estimate, this is going to be a single value. Confidence interval, that will be a range of the values. Let's look at this example. We were interested in the mean weight of all apples in the farm. So this is my farm, and I want to find out the mean weight of all apples. Since it is impractical to weight all the apples in the farm, we took a sample and find the mean weight. So for example, I only cut this part of the apples as my sample. And then I use the formula from the chapter 3. I find it out what is my sample mean. And this part of the sample, I would get the sample mean equal to 149 grams. And we call this as the point estimate, right? This is a one single value. And we use the sample mean to approximate that the population mean is about 149 grams. This is the idea from the chapter 3. Right? We cut it as a sample, use the formula, find out the sample mean, and we call this as the point estimate. And we use the point estimate to approximate the population mean. Okay, that will be about the same thing here. But think about it. Will I get the same result if I cut this part as my sample? Will I get it like 149 grams also? Yes or no, I may or may not get the same value. I may get a different answer. If I cut this part as my sample, I may get 130 grams. If I cut this part as my sample, I may get like 153 grams. So which one I should use to approximate to my population mean? In this case, we don't want to use the point estimate. Instead of finding a single value, we want to find a range of values. So that's why we want to find the confidence interval. And confidence interval provides more information than the point estimate. When we construct the confidence interval, we always say about the proportion of the time, either 90%, 95%, or 99% of the time. So if I only have a one point, this is called point estimate, and this is the single value. And let's say I assume this is going to be the normal distribution, and I want to work on 90% confidence interval. Okay, 90%, this is talking about in the middle part here, that will be 90%. And I want to use 90% to construct the confidence interval. So this is gonna be my confidence interval. You could see that will be a range of values. And the dot here, this is also represent the point estimate. That will be your sample mean. Okay, so 90% confidence interval is gonna be looks like this. Or I could use 95% confidence interval. 95%. So 95% will be including like more data. Okay, so you could see I'll be including much more data than the 90%. And in the middle, there'll be 95% here. So use the 95% to construct the interval. You could see my range of the values is going to be wider compared with the 90%. And then last one, 99%. So again, in the middle, that will be the 99% of the data. And think about it. What's your confidence intervals looks like? Will be wider than this or narrower than the 95%? We're including like more data, right? So you could see my range of the values gonna be much wider than the 95% and also the 90%. So it depends on what you guys are looking for. If you including like the higher percentage of the confidence level, you may have a wider range of the values. You will have a more confidence to including the true value inside on this confidence interval. And then after that, we're gonna draw the conclusion, say we have 99% confident that the true values is talking about your population parameter, lies within this interval. Okay, and we just say like this dot, this is gonna be your point estimate. For example, if we are working on the sample mean, this is gonna be the sample mean here. And then what is this guy? This part, we use the E to represent it. And this E means margin of error. Okay, margin of error. So if the dot here, this is represent your sample mean, how can we construct a confidence interval with a range of values? It will be looks like this. The population mean will be in between sample mean minus the margin of error, or sample mean plus the margin of error. So this is the idea. What is the confidence interval? Okay, we just talk about like the 90%, 95%, or 99%. And this is really typical percentage we use it in the statistic. Of course, you could make it like different. You could like construct like 92%, 93%, or 98%, or even you could do like 80% confidence level. And for example, if this is a 90% confidence level, so 90%, that'll be in the middle. And then we do have one called alpha. What is alpha? Alpha is an area of the left tail, talking about this here, plus the area of the right tail. That will be equal to the alpha. Okay, one more time. Area of the left tail plus area of the right tail, that will be equal to the alpha. So how can I find out what is my alpha equal to? Remember on the chapter 6, we talk about it, what is the total area under the curve? Total area under the curve, that will be equal to 1. And if we want to find out what is the alpha, we could subtract 0.90 from 1, right? So you're going to get 0.10 here. Okay, one more time. Total area under the curve is 1. We take out in the middle part 0.90, which is going to be 0.10. And 0.10 is talking about sum of the area of the left tail and the right tail. Okay, now I want to figure out what is the area for each tail. Okay, what is the area of each tail? We're going to divide it by 2, right? Okay, we assume like the 90% is in the middle. So we do have the same area from the left tail and the right tail. So after we figure out the alpha, we're going to divide it by 2. So you're going to get 0.05 on each tail. So you could double check 0.05 plus 0.05, which is going to be 0.10. 0.10 plus 0.9, that will be 1 in here, right? Which is going to be the total area under the curve. Okay, a critical value. Critical value is the number on the bottom line separating sample statistics that are likely to occur from those that are unlikely to occur. So critical value, you could see the z alpha over 2 in here. This is called the critical value. What is this guy? This is the number. You could see we draw the line from here. And this is the bottom line separating the sample statistic that are likely to occur. Likely to occur is talking about in this part in the middle. Okay, remember chapter 6, we learned that probability equal to the area. So on the area in the middle, this is talking about it will be likely to occur. And remember, we could construct 90%, 95%, or 99%, which is talking about we have a likely to occur in the middle part here. And then the right part in here, these two, this is talking about that are unlikely to occur. These two parts of the data we didn't include to my confidence interval. So the critical value, this is going to be the z-score, okay, z-score. And I want you guys highlighted the y tail, okay, y tail. You could see this is a normal distribution and this is should be the symmetric. And we have a 1 negative z-score and 1 positive z-score. But critical value is always talking about on your y tail. Means like you always have a positive critical value. Okay, you do have a positive critical value. It's always on your y tail. Okay, highlight your y tail. So the first step, we need to know how to find the critical value. Let's try an example. Find the critical values for a confidence level of 98%. So 98%, we assume that will be in the middle here. Okay, 0.98. First, I want you guys figure out what is the area for each tail. Okay, first figure out what is the area for each tail. I will find my alpha first, okay? Remember, alpha means area of the left tail plus the area of the right tail. So alpha will be equal to 1 minus the area in the middle, which is going to be 0.98. Then that will be 0.02. And then area of each tail. So I will be divided by 2, which is going to be 0.01. Okay, 0.01 in each tail. Okay, now this z-score will be my critical value. So I'm going to draw the picture again. And we know this is going to be 0.01. And figure out what is the area from the left. Okay, from the left, that will be including the area of your left tail. Okay, the total area from the left, what is it? Either you could do 1 minus 0.01, which is going to be 0.99, right? Or you could add up these two areas, 0.01 plus 0.98, which is going to be 0.99. Okay, so we want to find out the critical value. And remember on the chapter 6, if they given the area, how can you find your C-score? Okay, review your notes. If they given the area, how can you find your C-score? Are you using normal CDF or using the inverse norm? That will be the inverse norm, right? Inverse norm and the area from the left. Okay, area from the left. So that will be 2.33. So you know the critical value with the confidence interval 98% is 2.33. Okay, I want you guys keep in mind that if the confidence level is 98%, you won't put the 98% from here. Okay, 98% is talking about the area in the middle. You have to figure out what is the area for each tail and then find out the total area from the left. Okay, so make sure if this is 98%, it won't be the 98.98 from here. You guys need to know how to find the critical value. This is very, very important. Okay, this is the first step how you guys construct the confidence interval. If you guys make a mistake for the critical value, everything is gonna be wrong. Okay, now look at the second example here. Find the critical values for a confidence level of 95%. I want you guys trying to do it by yourself. Okay, 95%. So area in the middle, that will be 95%. First, figure out what is the area for each tail. Find out the alpha and then divide it by 2. So you could get the area for each tail would be 0.025. Okay, now figure out what is the area from the left. Okay, what is the total area from the left here? You can do 1 minus 0.025 or you could add up these two numbers. You will get 0.975. Then they given the area, find out the C-score. So we use inverse norm. You could get 1.96. Okay, so critical value with the confidence interval 95% is 1.96. Okay, one more time, make sure you know how to find the critical value. For the homework and the exam, you don't have to do everything just like here. Okay, I'm just doing my lecture. I show it to you guys really detailed. On the homework and exam, I only need this guy. Tell me what you're gonna use, what area you're gonna plug in, what is your final answer. Okay, I only need this one for the homework and the exam. If you want, you could do everything just like here. If you could handle it, I only need this part. So this is the first step, how you find the critical value. And then second one, we need to find margin of error. Okay, margin of error, the E in here. So look at the formula. Margin of error equal to critical value, which is going to be this guy, the Z alpha over 2. Okay, the previous two example, you guys know how to find the critical value. Times the standard error. Standard error is talking about this one. For these sessions, I need you guys remember all the notation. Remember what is this one? This is the population standard deviation, okay? Population standard deviation divided by square root of sample size n in here. Okay, look at the details in here. Margin of error is the difference between the statistic and the endpoints of the interval. For example, if the statistic were 0.6, okay, statistic here is talking about the point estimate, okay, the point estimate. And the confidence interval range from 0.4 to 0.8. So this is gonna be your endpoints. And then margin of error could be like 0.2. So try to sketch with this picture. The statistic, we assume this is talking about the sample mean, will be equal to 0.6. And then we know the confidence interval will be in between 0.4 and 0.8 here. This means we are confident that the population mean will be lying in between 0.4 to 0.8. So one more time, this dot will represent your point estimate, which is going to be your 0.6 in here. And then 0.4 to 0.8, that will be your endpoint. Remember what is this one? This is going to be your margin of error. So you could subtract it. 0.6 minus 0.4, you could get the 0.2 here. Or 0.8 minus 0.6, you also get the 0.2 in here. So right now, first step, we find out the critical value. Second one, we want to find the margin of error. If we know the margin of error, we could just plus minus with your sample mean. Then we could figure out what is your endpoints in here. Okay, confidence interval for estimating a population mean with population standard deviation is given. Okay, I want you guys to highlight this one. Okay, for the next part, the second part, we're gonna talk about it. How can we construct the confidence interval if we don't know about the population standard deviation? So this is talking about the given the population standard deviation. First, we need to check the requirement. The sample is a simple random sample, okay? Simple random sample. And we know about the population standard deviation, okay? We know this is gonna be the population standard deviation and this is given. Number 3, either or both of these conditions is satisfied. Population is normally distributed or n is greater than 30. And remember what is this requirement? This is from the chapter 6, section 6.4. We talk about the central limit theorem. Either original population is normally distributed or sample size is going to be greater than 30. So we could make sure that will be the normal distribution. So follow this step. First, find out the critical value. Okay, just like the example 1 and 2. Then find out the margin of error. Okay, you know the critical value from here and the population standard deviation is given. Sample size n is also given. So figure out what is the margin of error. And then construct the confidence interval. Use the sample mean plus minus with the margin of error. This is like the two different ways to write on your confidence interval. I usually use this one. Okay, but if you guys reading other statistic book, you could see the mean equal to this guy. This is the same idea, using the endpoints with the frequency. And then number 4, conclusion. You need to know how to draw the conclusion. Okay, let's try an example. The mean test score for a simple random sample equal to 100 students was sample mean 67.3. Population standard deviation of test score is 15. Construct a 99% confidence interval for the population mean test score. So first, they given the population standard deviation. Highlight this one also. Okay, When they given the population standard deviation, we'll be using the Z distribution. And they want to construct in 99%, we have the confidence level for the population mean test score. So we are working on the population mean. I want you guys to highlight this one also because session 7.2, we are working on the population mean. Session 7.1, we are working on the population proportion. And then session 7.3, that will be population standard deviation or variance. So you have to read the question carefully. Which population parameter we are working on it. And then after that, we're going to check off for the requirement. Simple random sample and the sample size is going to be greater than 30. So now, go for the step 1. Find the critical value. Okay, I want you guys try to do it by yourself. If you don't remember how to do it, review the example 1 and example 2. This time, construct a 99% confidence level. Okay, 99%. Okay, check your work. You could see the inverse norm, 0.995. One more time, if this is a 99%, you don't put 0.99 in here. You have to figure out what is the area for each tail and then find out sum of the total area from the left. Okay, so which is going to be 0.995. Use the calculator, you could get 2.58. Okay, this is going to be your critical value. And then find the margin of error. Use the formula. Okay, read the question one more time. What is your population standard deviation? What is your sample size? And then use your calculator. Okay, you should get 3.87. Okay, 3.87. And then step 3, construct the confidence interval. So figure out what is your sample mean, and then you do have the margin of error from the step 2 here. So plug it in, construct the confidence interval for the population mean. Okay. Sample mean will be 67.3, right? Plus minus the margin of error. You could get this guy. Okay, last one, conclusion. We're gonna write it down. We are 99%, okay, because we are working on the 99%. We are 99% confident that, so look at here, the population mean test score is between with these two numbers, okay? You guys need to know how to draw the conclusion by yourself. On the exam and the homework, it won't be just fill in the blanks. Okay, on your notes right now, that's a fill in the blanks here. But on the homework and exam, you need to know how to write the conclusion with the complete sentence. On the homework and the exam, I need you guys show me all those words. Okay, I need to see these one. And with your answer. Margin of error also. Don't use the calculator to just calculate it. I need you guys using the formula. Okay, plug it into the formula, show me your work and your final answer. Confidence interval here also. Okay, and you can use your calculator to double check your work. Okay, let's try to use the calculator. You're gonna click on the stat. Okay, stat. Use the arrow button, go to the right. And then go down here. That's a z interval. Z talking about the z distribution. You could see the critical value. We have the z in here. Okay, z distribution. Interval talking about confidence interval. Okay, z interval. Enter. So it depends on the questions. They give you a set of the data or they give you the statistic. Statistics means like they already find out what is the sample size, what is the sample mean here. So in these questions, we're gonna use the statistic. Okay, first, population standard deviation. Population standard deviation, that will be 15. Enter. Sample mean 67.3. Enter. Sample size, that will be 100. And then confidence level. We are working on 99%. Don't put the 99 in here. Put 0.99. Okay? Go to calculate. Enter. So you're gonna see this is gonna be the confidence interval, 63.43 to 71.16. You could see on my calculation here is a little bit off. If I wanted up 63.44, but here I only got 63.43. It is because for my critical value, I only take like 2 decimal space. If you try to take like more decimal space from here and more decimal space from here, you could get the same answer from your calculator. Okay, but on the exam or homework, as long as you show me all your work, I don't take out any credits from here. Okay, you could follow the instructions on the notes here. Okay, next example. Suppose score on exam in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 score is taken and gives a sample mean of 68. Find a 90% confidence interval for the true population mean of the statistic exam score. Okay, I want you guys try to do it by yourself. Find the critical value, margin of error, construct the confidence interval, and write down the conclusion. Let's try to work together. When you have a 90% here, you could get inverse norm for 0.95, right? 0.95. You should get 1.645. And then use the margin of error. Again, highlight the population standard deviation. Okay, when we have a population standard deviation, we'll be using the Z. Okay, Z. So you could get 0.8225 here. And then construct the confidence interval. You're gonna get this one. Okay, conclusion. For the chapter 7, make sure you know how to find the critical value, okay? If you make a mistake here, you're gonna make a mistake for the margin of error. And then you're gonna make a mistake for the confidence interval also. So please double check how to find the critical value. If you don't remember, review the video lecture. We have the first 2 examples, teach you how to find the critical value. We talk about this picture when we're working on the margin of error, right? Let's say this is a 90% confidence level. We have the sample mean, we have the endpoints, and we know the margin of error is going to be 0.2 here. And now I say, I want to keep the 90% confidence level, but margin of error, this is too big for me. I want to restrict it to 0.1, okay? I want to cut it half, okay? I want to make this narrower, but I want to keep the 90% confidence level. So I want my pictures looks like this. What can we do for that? Okay, I'm not asking you guys to find out the endpoints in here. I want to know what is my sample size n. Okay, how many sample size do I take, and I could restrict the margin of error is going to be 0.1 here. We'll be using like this formula. This is for you guys determine the sample size if we know about the margin of error. So you have the critical value, population standard deviation, and margin of error is given. And you're gonna figure out what is your sample size n in here. And keep in mind, sample size is always a whole number. You don't get half person, okay? And you always round it up. Let's say you get 120.1, you're gonna round it up to 121. Okay, forget about the rounding rules. Greater than 5, you add 1. Less than 5, you replace by the 0. Okay, you always round it up to the next whole number. Scientists want to estimate the mean weight of mice after they have been fed a special diet. From previous studies, it is known that the weight is normally distributed with the standard deviation 3 grams. How many mice must be weighed so that a 92% confidence interval will have the margin of error 0.5 gram here? So first, how many mice here? We want to determine the sample size. And then, they given the 92% confidence level. So first step, I need you guys find out the critical value. Okay, 92% confidence level. Find out the critical value. So you could get the inverse norm 0.96, right? And then you should get 1.75. Okay, what is the standard deviation? Okay, we need to figure out what is the population standard deviation. That will be 3 grams here, right? Standard deviation will be 3 grams. What is the margin of error? Margin of error will be 0.5 here, right? So E equal to 0.5. So plug in on this formula. You could get 110.25. Is it your final answer? No, right? Remember, sample size is always a whole number. And even though this is 110.25, okay, this is less than 5, but you always round it up to the next whole number. So final answer will be 111. Okay, you need 111 mice to get the 92% confidence and with the margin of error 0.5 gram. Okay, for the first part, we know how to construct the confidence interval for the population mean with population standard deviation is known. Okay, we know that we given the population standard deviation. Second part, we're gonna work on the confidence interval, which is population standard deviation is unknown. Okay, they don't know this number, but they're gonna give you the sample standard deviation. Okay, they're gonna give you the sample standard deviation. In this case, we'll be using a new distribution. Okay, this is called the student t distribution. Instead of using a normal distribution z, okay, this is something new. On the chapter 6, we only focus on the normal distribution. We never talk about the student t distribution. So I want you guys highlight here. When we want to construct the confidence interval for the population mean and sample standard deviation is given, okay? S stands for sample standard deviation. So look at the student t distribution. Okay, look at this picture. You're gonna see the black line here. This is called the standard normal, okay? This is talking about your z distribution, okay? The one we're working on the chapter 6 or the part 1 from here, okay? The black one, that will be the standard normal distribution. And for the t distribution, I want you guys to look at the brown one here, okay? The brown line in here. You could see, compare with the standard normal, the t distribution is going to be more spread out, okay? The more spread out. And this is specific like t with 1 degree of freedom, okay? I'm going to explain what is the meaning of the degree of freedom later, okay? You could see t equal to 1 when you have a small degree of freedom. The distribution is more spread out compared with the standard normal. If we increase the degree of freedom to 4, that with the blue one here, it will be approximate, close to the standard normal. If we keep increasing the degree of freedom until to the 10 here, that would be the red one, really close to the standard normal distribution. Okay, so the student t distribution is also looks like the normal distribution. It's just more spread out. And it is a symmetric, okay, symmetric. And in the middle is 0, so the t distribution can be positive or can be negative here, just like the z-score. And then we need to know how to find the degree of freedom, okay? We need to know how to find the degree of freedom. Okay, now let me explain what is the meaning of degree of freedom. Definition: degree of freedom for a collection of the sample data set is the number of the sample values that can vary after certain restrictions have been imposed on all data values. So what is the degree of freedom? Look at this example. If 10 test scores have the restriction that the mean is 80, okay? So on this example, my restriction is the sample mean has to be equal to 80. So think about it. I have a 10 test score. So this is my 10 data. And I want to find out the sample mean. So I add it all up divided by 10 in here. It has to be equal to 80. This is my restriction. Now, I'm gonna multiply by 10 for both sides. Okay, so multiply by 10 here, cancel out. Multiply by 10 here, I got the 800. So means like sum of 10 data has to be equal to 800. What does the degree of freedom means? Degree of freedom means for the first 9 data here, it can be anything. I could make up any value for the first 9 data. But for the last one, it has to be fixed. Because after I add the last data, I will make sure it has to be equal to 800. So in this example, I would say my degree of freedom will be 9. I do have a 9 degree of freedom to assign any values. But for the last one, it has to be fixed in order to get the 800. So how can we find the degree of freedom? It's going to be equal to n minus 1. Okay, if we have a 10 data, means I have a 9 data of degree of freedom. If I have a 20 data, means I do have a 19 data of degree of freedom to assign any values. Okay, using the TI-84 plus calculator, find the critical value of T alpha over 2. Okay, you're gonna see this time my critical value become the T, okay, instead of the Z. Means we are using the student T distribution instead of the normal distribution. And you can see I only say using the TI-84 plus calculator because only TI-84 plus calculator have this function. If you are using the TI-83 plus calculator, you need to do the programming. I already posted the YouTube video to teach you guys how to do the programming for the inverse T. Again, if you're using the TI-83 Plus or TI-83 calculator, you need to do the programming in order to use the inverse T here. If you're using the TI-84 Plus calculator, you will be fine. Just follow like this instruction. So we're gonna do the second bars. You're gonna find out the inverse T here. Okay, inverse T. And then you need to put in like two numbers. Area to the left, similar to the Z distribution. And then comma, degree of freedom. Again, degree of freedom is gonna be n minus 1. And then look at the positive number. Your positive number here, that will be your critical value. I will show you guys how to use the calculator with this example. Okay, simple random sample of size 13 is drawn from a normal population. Find the critical value for a 90% confidence interval. So first, we know the sample size is going to be equal to 13. The step is similar with the first two examples, how to find the Z critical value. So we have assumed this is a normal distribution again, and 90% in the middle. So in the middle is going to be 0.90. Figure out what is the area on each tail. So it's going to be 1 minus 0.90 divided by 2, which is going to be 0.5. Okay, exactly the same step, just like the example 1 and 2. Now, what is the critical value? We'll be using the inverse T, area from the left. Again, find out the total area from the left. So you could add up these two numbers, which is going to be 0.95, or you could do 1 minus 0.05, comma, degree of freedom, n minus 1, okay? Sample size is 13, 13 minus 1 is going to be equal to 12. So you should get 1.782. Okay, let me show you guys with the calculator. Second bars, you're going to see the number for inverse T. Enter, area from the left, 0.95, comma, and then degree of freedom, n minus 1, which is going to be 12. Enter. You can see my calculator is running right now, 1.782. Okay, 1.782. If you go to the second bars, you didn't find the inverse T. I know like some TI-84 calculator, they may not have this function either. So again, you need to do the programming. Okay, I post a YouTube video on Canvas. So watch that video, follow the instruction, how to do the programming in order to use the inverse T. You need to know how to do that because on the chapter 8, we need the inverse T again. Okay, procedure for constructing confidence interval for population mean when population standard deviation is unknown. Okay, so this is talking about S is going to be given. Okay, sample standard deviation is given. So simple random sample and the central limit theorem. Okay, population is normally distributed or sample size is going to be greater than 30. So first, find out the degree of freedom and the critical value, just like the previous example. Second, find the margin of error. This formula is really similar to the part 1. Only difference is this is a T and they use the Z. And the S, okay, they're using the S. This is a sample standard deviation, okay? Sample standard deviation. After you know the margin of error, construct the confidence interval. And then conclusion. Okay, really similar. Okay, example. Sample of 123 people, aged 18 to 22. Report the number of hours they spent on the internet is an average week. Sample mean was 8.2 hours with the sample standard deviation of 9.84 hours. Highlight the sample standard deviation. Okay, this is the S. When S is given, we want to use the student T distribution. Okay, and assume this is a simple random sample from the population of the people aged 18 to 22 in the United States. Construct 95% confidence interval for the population mean. Population mean. The population mean number of hours per week spent on the internet by the people aged 18 to 22 in the United States. So first, find out the critical value. Okay, you're gonna use the inverse T, area from the left, and the degree of freedom. Okay, degree of freedom is n minus 1. So 123 minus 1, which is gonna be 122. Use the calculator, you should get 1.98. Okay, find the margin of error. So use the formula. You have the critical value here already. What is your sample standard deviation? Okay, one more time. Read the question carefully. On the homework and the midterm, the questions kind of mess up. It's not in order. So if this is the sample standard deviation, you're using the z distribution, everything is gonna be wrong. Okay, you may got 0 in the questions in here. So homework and exam, read the question carefully. Sample standard deviation is given, we use the t distribution. Okay, it match with your formula. This is S. Okay, you should get 1.7567. Okay, then construct the confidence interval. Plus minus using the sample mean plus minus the margin of error. Okay, you should get this. And then draw the conclusion. Make sure you know how to draw the conclusion. We always say 95%, right? So we are 95% confident that you could copy from the questions here. Population mean number of hours per week spent on the internet by the people aged 18 to 22 in the United States is between these two numbers. Okay, let's try to use the calculator to check your work. Okay, so we're gonna go to the stat, go to the test, go down. Okay, this time we are working on the t distribution, confidence interval. Okay, the part 1 will be using the z, right? This time we're using the t distribution, confidence interval. Enter. And then we have the statistics summary. So sample mean, that will be equal to 8.2. The S here, this is a sample standard deviation, okay? Make sure the question is given the sample standard deviation. That will be 9.84. Sample size and 123. And we are working on 95%. So 0.95. Calculate. Okay, enter. So you should get 6.44 and 9.96. Okay, 9.96. Okay, you could follow this procedure on your notes. Suppose you do a study of acupuncture to determine how effective it is in the relieving pain. You measure sensory weight for 15 subjects with the results given. Use the sample data to construct a 99% confidence interval for the mean, okay, the mean, for the population from which you took the data. So this time they're gonna give you the data set instead of the statistics summary. So first, find out the critical value. And since they give you the data, right, you don't have the population standard deviation. From the sample data, you only can get the sample mean and the sample standard deviation. So for the critical value t here, first determine what is your sample size. What is your n equal to? You do have a 15 data, right? So n equal to 15. So the degree of freedom will be equal to n minus 1, which is going to be 14. And we are working on 99%, okay? So you should have this number here. Inverse t, 0.995, degree of freedom, n minus 1. You could get 2.977. Okay, step 2, find the margin of error. Since they're given the data set only, we don't have the statistics summary. We don't know what is the sample mean. We don't know what is the sample standard deviation, right? Do you guys remember how to find out the sample mean and the sample standard deviation if I give you guys a set of the data? Remember the midterm one? If I give you guys the data, how can you determine the sample mean and sample standard deviation? You could use the formula or you could use your calculator. So let me show you guys how to do it. I'm going to go to the stat. Number 1 added. So let me clean up the data here. Highlight the L2, click clear, enter. Highlight the data, highlight the L1, click clear, enter. So now I'm gonna plug in this data. We have a 8.6, enter, 9.4, 7.9, 6.8, 8.3, 7.3, okay, input the data. So we do have a 50 data in here. Now go to the stat, go to the cal, choose number 1, one variable statistic. Second, 1 for L1. Enter. So we have the sample mean and we have the sample standard deviation. Try to get more decimal space, okay? Don't take only 1 or 2, okay? I need a 3 decimal space here, so you want to take more than 3 decimal space from the data. So let me write it down, my sample mean and sample standard deviation. Now, find the margin of error. Okay, check your work. You have the critical value here times sample standard deviation divided by the square root of 15. You should get 1.285. And then plus minus the sample mean. Okay, you have the sample mean plus minus with the margin of error. You should get this. And then draw the conclusion. So we are 99% confidence interval, okay? And the weight is going to be in between these two numbers. Okay, check your work with the calculator. So for this one, they give us the data set instead of the statistics summary. So I already have the data set on my L1. Now I'm gonna click on the stat, go to the test, go to the t interval. We are working on the t distribution confidence interval. And I will choose the data here, okay, because we have the data. And then my data set is on L1, okay, so I keep it for the L1. Frequency, keep it as 1. We are working on 99%, so 0.99. And then calculate. So double check your work. you have the confidence interval 6.94 to 9.51. And then double check your sample mean 8.2267 and sample standard deviation 1.6722, and the sample size is going to be 15. Okay, that's it for the session 7.2.